So yesterday we started with the fact that we did the remainder theorem and factor theorem. And again, the easiest part or the hardest part about this is the fact that if you're doing the remainder theorem or factor theorem, it does not really mean anything crazy. It means you say whatever you think the zero is, you plug it in. And if you get zero, then it's a zero. If you don't get zero, then it would actually be the point on that graph. But it also, when you do division, whether it's long division or synthetic division, it's just going to be the y value of that point. But it's also going to be the remainder if you chose to do long division or synthetic division. Yes, he got me started. And then we're going to do announcements after the end. They're going to do them. Oh, they're going to do them out. Okay. So anyway, so it says use. So what this happens, it says the remainder r gives the value of x at x equals k. Stop.
Pardon the interruption. Good morning, FCHS, and welcome back to another great day. Remember, we are driven by our school mission statement, Franklin Community High School, where students always display pride, perseverance, responsibility, independence, dedication, and excellence. Today is Tuesday, October 1st, and the TIC Center SAT word of the day is banal. Banal means commonplace, trivial, or trite. My friends were arguing about the banal things, but I stayed out of it because it wasn't worth losing a friendship. If you missed the Student 10X grant meeting yesterday and you would like money to support an innovation passion that you have, then be sure to check your email today. Mrs. Foraker will be sending out more information. You can also talk to Mrs. Bailey, Miss McCain, or Mrs. Foraker for more information. That's all the announcements we have time for today. Please stand for a moment of silence. And now the pledge. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Make it a great day, FCHS.
Okay, we're going to start this all over again. But anyway, so we finished with the remainder and the factor theorem. And so we know that if you think you have a possible zero, then you plug it in. If you get zero, it's a zero. If you don't get zero, then it would actually be the remainder if you had long division or you did synthetic division. But it is still actually that point on the graph at that given x value. So it is actually a point on that graph. So the other option we're going to have now is because we're trying to find these zeros, whether it's a second degree, third degree, fourth degree polynomial. The next test we have is that rational zero test. And so what is the rest? Sometimes it's called a rational root test. Sometimes it's called a rational zero test because they're all synonyms of each other. And so the rational root test is exactly looking for what they call rational roots. So they basically are anything that can be represented as a fraction or a decimal. So you're not going to find your irrationals here. You're not going to find your square roots. You're not going to find something that you'd have to use the quadratic formula for or complete the square form for. You won't be able to find those in this method. But this is something that you can find due to if you could try to factor it in some things that you would be able to get zeros out of that. So here we are. The rational root theorem says is that you're going to use your constant, which is your p, over your coefficient of the highest degree, which is your q. And so you're going to write every single combination. P and Q have no common factors other than 1. Then you're just going to look at the p values, and that'll be the only thing that you're going to put down here. So let's flip it over, and we're going to go run through this. So how do you find how do you use the rational zero test? Well, first of all, you list all the rational zeros or all the rationals for the numerator, factors, and the denominator. So this is your constant. This is the factors of the leading coefficient. And so you're going to find all of those numbers. So let's look real quick at what we have. So as we look down to this definition, this is your P. This is the coefficient. This is Q. What are all the ways, all the factors of P? All the factors of P. Well, plus or minus what? 1. I can take 1 times 1, negative 1 times negative 1. What are all the factors of Q? Plus or minus 1, because there's no number there, it's understood to be 1. So it's going to be plus or minus 1. So you're doing every single combination of that ratio. You're doing every single combination. Well, what would that combination end up being? Plus or minus what? 1. So that's our combination. You would do every single combination that you possibly could get. And so you're going to say, oh, well, find the rational zeros. Well, we think they're 1. Well, when I look at this, what is that? Right there's a graph. Is 1 or negative 1 going to work? Well, again, we have to kind of really know what it looks like. Well, we know our scale is going to be negative 1, negative 2, negative 3. So is it crossing right there at negative 1? No. Okay, so again, this is where we're going to probably get your calculator out if you have it. Go ahead and graph this and see that you can validate and verify. Because you're going to want your calculator as we go through some other ones anyway. Okay, so you type in x cubed. X cubed plus x plus 1. And again, you're going to see the graph. They have their scale from negative 3 to 3 all the way around. So we'll change our window as well to match that. Negative 3, 3, went up by 1. Negative 3, 3 goes up by 1. Okay, and so when you look at this, let's just kind of go back down memory lane, if you will. How many possible real zeros are there? 3 real. So remember, our number system is complex. And so as soon as we say that all of our numbers are complex, every number can be written as a complex number, which has a real and an imaginary part to it. Then it automatically breaks into reals and imaginaries. And then our reals break down to rational and irrational. So we're looking at just the rational roots. So when I look at this and I say, okay, well, it doesn't look like that is. I do have one real zero. I do have one place where it's really crossing the x-axis, but it's not a rational root. I don't have any rational roots, and that's okay. If I wanted to find this 0, let's just kind of, again, go down memory lane. What interval of length 1 would I find this real 0 in between? Negative 1 and what? 0. If I actually really wanted to find it as a decimal form, what would I do? Second calc, what? 0. Hit enter, get to the left of it. Hit enter, get to the right of it. Hit enter. Then once you have your window, hit enter, and the 0 is around 0.68, right? 0.68. Negative 0.68, I should say. Negative 0.68. So did we have any rational roots? Did we have any nice, neat little fractions that we could write? Or nice, neat little terminating decimals that we can use? No. So this would fall under the irrational category. So we don't have any, so there's none here. Good? Questions on that? So there are none. That's okay, but we just got to be able to investigate that. There's an irrational one. So here you go. It says you might want to use a graphing utility to speed things up. And you can either draw the graph by hand or use a graphing utility to get your estimates. Use the intermediate value theorem along with it to give the approximations in case they are irrational, which is what we just did. So here we are. Find all the possible rational zeros. Find all the possible ones. So let's look. What's P? P is 3. And so what are all the ways you can multiply to get 3? Plus or minus 1, plus or minus 3. So we just kind of list them in terms of 1, 2, 3, 4, just like a number line. And then what is the Q? What is the Q? 2 is the Q. And so what are all the ways to get 2? Plus or minus 1, plus or minus 2. Now I need every combination. Yes? We could have gigantic numbers, but due to the lack of being able to test and quiz on that, probably not so much on a test or a quiz. Okay? Yes. So we need possible rational zeros. That's what I want to know. Which ones could possibly work? I need every combination. So I will tell you, this won't cut it on a test or a quiz. This right here, this is just kind of the makeshift, but I actually need to know that you know how to come up with these. So what are the possible rational zeros? What's 1 over 1? Plus or minus 1. What's 1 over 2? Plus or minus 1/2. Then we have to go do 3. What's 3 over 1?
Just 3.
And then what's 3 over 2. Now, if you get repeaters, like say that something can be reduced to 1/2 or something can be reduced to 3/2, you don't need to list it again, right? Once it's listed, it's listed. So you don't need to do every single combination and keep them if they can be reduced to something that's already been listed, right? So if it's already been listed, you don't need to relist it. So these are all the combinations. And so I went ahead and threw the graph up here just so you can see it, but you might want to throw it in your calculator as well so you can see that from there. But as you can see, there's how many possible real zeros? There's possibly at most 3. It looks like it's crossing how many different places? 3. So maybe they're all rational, maybe they're not. So let's go ahead and check that. Go ahead and graph it because I'm going to tell you the easiest way to do this. So go ahead and throw this in your calculator, 2x cubed. Again, please double check the equation because if you put it in wrong, it's going to use the equation that you put in. So we're going to graph it. Again, I'm going to kind of look at this scale. What's this scale? Okay, it looks like it's -4 to 2. So again, you can kind of see that I have it. It doesn't really matter what the scale is as long as you see them all, but I'm going to match the picture on the paper. So the x min is -4. The x max is 2. It appears it went up by 1, 2, 3, 4. It went up by 1. The y minimum looks like it goes down to what? -2. And it goes up to what? 16. So 16, but it looks like they went up by how many on the y scale? 2. So again, if we want to match it, you don't have to match it perfectly. You just got to get them on there and see it. So hit graph. So now it should look like it. The thing I want to caution you on, because it does happen, sometimes these are so close together, you only see one. So you need to make sure that you're actually seeing the entire graph. If that means you zoom in, you zoom out. So here's what you want to hit, because you want to use the calculator to speed up the process. You're going to hit second trace, which means you want to do what with something? Calculate, and you're going to go for value. Okay, you're going to go for number 1, I think. Second calc value. Okay, so you're going to hit that. Now, if you go second calc value, you're just going to type in. You don't have to keep hitting that. So let's look. Use the graph. Use it to your advantage. What does that look like it's going to be? What does this look like that is? You think that's at what? -3? So let's punch in -3. If it is a 0, what will it come out to be? 0. Oh, one rational root is -3. What's the other rational root? Well, that one looks like it's going to be less than 1. So maybe what out of my list? 1/2. So we type in 1 divided by 2. Oh, that was worked. And then what's this one? That one looks like it's maybe right at 1. And it was at 1. So I found all 3 of them. So all 3 of them, and I just confirmed it with the calculator because I saw the y value was 0. Correct? Not bad, correct? But again, second calc value, you can knock out a whole bunch of them with that feature. And you can find them really quick. If not, you can also just substitute them in by hand and do the math on your own and see that it comes out to be 0, right? Your choice. Okay. So next, so possible rational roots. Everybody good with that? I think you also did that in algebra 2, so I don't think that's something new. But anyway, so now you've got Descartes. Well, here we go. It says, you know that an nth degree polynomial can have an nth degree. So if we have a cube, we know we're going to have at most 3 real zeros. Not a guarantee. So sometimes it just helps to figure out, well, do we have any real zeros at all? And so, for example, if we have, using our transformation knowledge, if I had x squared plus 1, you know that's a parabola, and we move it up 1, then we know that's never going to have any x-intercepts because it's going to have a minimum at 1, and then it just goes up from there. And so we know that would have no real zeros. If I have x cubed plus 1, then we know that would have 1 real zero because we know the way the parent graph goes. And if I move it up 1, it's still going to cross the x-axis. And so you're going to be able to have 1. So then there's good old Descartes that sat around on a good old Saturday afternoon and thought, well, how can we shed more light on the zeros of a polynomial? And so Descartes said, you know, let's look at the signs of a polynomial. And if the signs of a polynomial, if they change, however many times they change from one term to the next, That's going to be how many possible positive real zeros the polynomial will have. If I look and plug in a negative x and see the effect on the signs, then I can go back and do the same test and be like, oh, that's how many times it possibly could cross the negative side of the x-axis. And that's the possibility. And they go down by even numbers every single time. So let's put this into practice and see what we have. Okay. So if I use Descartes' rule, here we are. Let's look real quickly down here at this example. We're just going to pass this example. Determine the possible positive and negative real zeros. And again, it goes back to understanding what the directions are asking you. So if I want possible positive real zeros, that's saying, hey, how many are on this side? This is the possible positive real zeros. This is the possible what? Negative real zeros. That's what we're talking about. So it's like, again, you're just analyzing something. You're looking at the graph and you're analyzing to see what it has. Well, we look at this and we're going to start out with the possible positive. If I want to do that, I'm going to keep everything the same. It doesn't really have to be in descending order. If you want it to be, you can put it in descending order. So I'm going to look to see how many different sign changes there are from one term to the next. Sign changes. That's all I'm going to look at. So again, and so when I look at this, I'm going to say, all right, well, did I change signs from 3 to -5? Yes, check that one off. Did I change signs from -5 to 6? Yes. And did I change signs from 6 to -4? Yes. So how many times could this graph, this function, before I ever graphed it, how many times could it possibly have positive real zeros? It could possibly have how many? 3. So the answer would be that this would be 3 or 1. It goes down in increments of 2. So how many times is it guaranteed to have a real zero? It's definitely going to have how many? 1. Right? It's definitely going to have 1. It's going to have 1 real zero guaranteed because, again, it goes at most sign changes, and then it goes down by increments of 2. So if I had 5 sign changes, we could have 5 real zeros crossing on this side of the x-axis. We could have 3, or we could definitely have 1, and we'll have 1. Does that make sense? Okay, so then what happens is, well, how do you do the possible negative ones? Well, you have to put in a negative x, and you have to see, because these are all negative x's, so we have to see how it changes the term. And so we do the math on the negative, just like we did if it was odd or even. And I think some of you struggled with that. So you're not going to put anything for that constant. So we have to do the math on the negative and say, okay, well, when I take a negative, no matter what it is, and I cube it, what's the result going to be when I multiply it by a positive 3, positive or negative? It's all going to come out to be negative. If I take a negative x, no matter what it is, and I square it, it comes out to be positive, then multiplied by -5. So it'd be a -5x squared. And then if I multiply 6 times a negative x, that's going to give me a -6x minus 4. So again, we are not determining the sign changes from doing that math. We're now, once we have the negative result on how it affects the term itself, the individual term, we go back and look at how many sign changes are between the terms. So how did the sign change between -3 and -5? No. Did it change between -5 and -6? No. Did it change from -6 to -4? Did the sign change? No. So what does that mean? That means how many possible negative real zeros will I have? So in other words, how many times is it going to touch or cross this negative side of the x-axis? None. 0. None. Okay, so now let's pretend. Let's say we did that and we had 4 different sign changes. Well, what would that mean? It means it would cross the negative side of the x-axis 4 times, 2 times, or none at all, right? So always go down in increments of 2. 4 times, 2 times, or none at all. Good? Questions on that? Okay. So now here we are. We're at the end. Find all the real zeros. And I might stop right now. I see people on their phones not paying a bit of attention. And I'm not quite sure what that is. And I see the phone's out, which that shouldn't even be happening. And total back turn. So that makes it a little bit interesting as well. But anyway, here we go. Find all the real zeros. That's the directions. Find them all. So what do we know first? And I'm going to kind of go overboard on this. What do we know? Well, I'm going to just kind of run through it. Let's just kind of run. Possible, positive, real zeros. How many of those you think we ought to have? Let's just analyze the thing for just a tad bit. Possible, positive, real zeros. How many do you think we ought to have? 1, 2, right? 2 or 0. So we either know it's going to cross this side of the x-axis twice or not at all. Does that make sense? Okay, because of the possible sign changes. Then it says possible negative real zeros. Okay, so what does that mean? Well, I have to plug in a negative x. If I plug in a negative x, what's that going to give me? 10 negative x to the fourth minus 15 negative x cubed minus 16 negative x squared plus 12 times negative x. So what would that give me? 10x to the fourth? Yes.
So on the last problem, when we plugged in negative x, you added a negative in front of the leading coefficient. Can you not do that on this one?
No, because that's just what the math came out to be. So like when I plugged in this negative, you have to say,
Oh, it's your equal sign. Never mind.
okay, you good?
Yep.
Okay. So then if we're going to get 10x to the fourth, and then this would give me what? Negative times a negative would end up being a positive. And then that's going to be negative 16x squared. And that would give me minus what? 12x. So how many possible negative real zeros would I have? So in other words, how many times do I think it's going to cross this side? How many sign changes do we have? 1. So how many times is it going to cross that side? 1. Does that make sense? There's 1 sign change out of this whole thing. So it's guaranteed to cross the side of the x-axis once. Does that make sense? It's all about analyzing. It's all about talking about what it looks like. So now let's begin. So find all the real zeros. So I'm back and I said, okay, well, I kind of did my homework. I know that I can either have 2 or none. I'm definitely going to have 1. And so now let's go try to find them. So what are we going to do? How are we going to find it? And this is no holds barred. It's like whatever you want to do, you can do. But what's the very first thing you should always look for? GCF. Number one thing is a GCF. Do you have a GCF? Yes. And what's that answer? So we got f of x is equal to an x. Factor that out. It's going to be 10x what? Cubed minus 15x squared minus 16x plus 12. Now, what's the next thing? The next thing you could do is you could look at this and try to factor by grouping. You have 4 terms left, and so you can factor by grouping. What do I mean by that? I mean that I could like group these 2 up together, group these 2 up together, and when I did, I changed the sign of the 12. And I would try to see if they could have a GCF so that what I have left in parentheses, they have something in common. And I look at that and I can tell that's not going to happen. Because if I did this, this would be a 5. And we would have a 5 in common, which would be a 2. Here they have in common a 4, which would leave me with a 4. So it's not going to work. So again, it's just that practice of doing it. So now what do you want to do? So factor by grouping would have been far the easiest thing to do if it would have happened, but it doesn't. So now where do you want to go? You only have one option, and that's what? Not quadratic, because I have a cube. Now once I get down to a quadratic, when I have a square and that's all I have left, I could do the quadratic formula, but that wouldn't give me real zeros. That would give me real zeros, but they'd be irrational. So now what do you want to do? That's it. We're stuck. We have one more option. P over what? Q. P over Q. Could you do long division with what? With X? You could do that. You could do a long division with X if you wanted to do that, right? And you can sit there and try to divide that. If you had a factor, well, it would be X is what we would choose. But I'm going to choose this P over Q just to give us some more practice, okay? So what's P over Q? What are all the combinations of P? Plus or minus 1, plus or minus what? 2, plus or minus what? 3, plus or minus what? 4 plus or minus 6 plus or minus what? 12. This goes back to Ava's question. Are we going to have a bunch of them? Yes, sometimes. And then what's the other one going to be? Q? What are all the combinations to get a Q? Plus or minus 1, plus or minus 2, plus or minus what? 5, plus or minus what? 10. So again, this is possible. What are we getting ready to write? Possible rational zeros. Again, just kind of doing that so we know. Possible rational zeros. So what is every combination? So what are the possible rational zeros? 1 over 1 would give us what? 1. 1 over 2. 1/2. 1 over 5. 1/5. 1 over 10. Right? Those are a lot of decimals right next close to each other. Then what's the other combination? 2 over 1. 2 over 2. We already have it. Plus or minus what? 2/5. Plus or minus 2/10. What's 2/10? 1/5. We already have it, so we don't need to write it. Now let's go plus or minus what? 3. Plus or minus 3/2. Run off the paper. Plus or minus what? Ready to go to 4, aren't we? 3/10. We're at 3, right? We had 3/5. Where were we? We're at plus or minus 3, plus or minus 3/2, plus or minus 3/5. Plus or minus what?
3/10.
3/10. Now we're ready to go to what?
4.
Plus or minus 4. Plus or minus 4/2. 2. Plus or minus what? 4/5. Plus or minus what? 4/10. What's 4/10 reduced? 2/5. We already have it. And then we're ready for the 6. So we're going to get plus or minus what? 6. Plus or minus 6/2, which would be what? 3. Plus or minus what? 6/5. And then plus or minus what? 6/10. But what's 6/10? 3/5. We have it. Plus or minus what? Finally at the end, thank goodness. 12. Plus or minus what? 6. Plus or minus 12 what? Fifths. And plus or minus 12 what? Tenths. What's plus or minus 12 tenths? 6/5. Do we already have it? So those are all the possible ones. And so what are you supposed to do with all those? You can either throw them in and test them, correct? Now here's the best part. And we're going to do that. So let's go ahead and graph this. Y equals. Clear. So you're going to get 10x to the what? 4th minus 15x to the 3rd. Oh, actually, which one do we want to do? It doesn't matter. Okay, 10x to the 3rd. I'll explain that in a minute. Minus 16x squared. Plus 12x. Okay, again, double check it. Make sure you typed it in right, because whatever you type in, that is what your calculator is going to do. So we graph it. Okay. And so again, as I see my graph, that's just from the last one. I didn't really change the window, but I want to change it just a little bit. I think I'm going to keep these the same a little bit. I'm going to go in and change this one to a positive 4. Correct? And then I'm going to change this negative 6, that 16, I'm just going to change it to 5. And I'm only going to go up by 1 because I don't really need to know all that stuff. Okay, so I'm just changing my window to negative 4, 4. Scale is 1. The y min -2. The y max 5. Because again, I'm going to bring something else up that we should be aware of. Do I have the entire graph? Do I need to worry about going out to 12? Because I should be able to figure that out. And again, how do you figure out if you have the entire graph? The end behavior. As you go to the right, and this being positive, we know we go to the right, it's going to rise. As I go to the left, it's going to what? Rise. Do I have it? Do I have the left and right rising? Yeah, so I know I have the entire graph. So we know that 12 is not an option, 6 is not an option. But you want to make sure that you have the entire graph and you know when to look. So I'm going to look and say, okay, well, what are the possible rational zeros? Well, looks like there's how many? 1, 2, 3, 4. Obviously, the first one was what? 0. Second, calc, value, 0. Yep, so 0 was one out of that list. What was the other ones? Well, it looks like that's kind of right in the middle. So I'm going to go with 1 divided by 2. I was wrong. It's a little bit more than 1/2. So this is where your judgment comes into play. What's another number that's a little bit more than 1/2? 4/5. Nope, that wasn't it. 3/5. Oh, that's closer. So what's between 3/5 and 1/2? 2/5 maybe? Nope, that was less. 4/5. 3/10 maybe? That's a little small. I'm not seeing one, do you? Anybody else figuring one out? Huh?
It's 0.56, so I don't think that.
So it's not on there, is it? Because we have the zero method? Good. That's lead us into something else that we're going to do in a minute. Well, what about this one? Does this one look close to 2? What looks close to 2? Which one looks close to 2? 3/5, 3/2. I'm not seeing anything, right? Huh?
It is 2.
It is 2, so let's put 2 in there. Oh, it's 2, so x equals 2. And what about this guy over here? Maybe -1? Nope. -1/2? Nope. What do we got for -1? What do you think? Any negatives you thinking? Anybody finding one? 3/5 maybe? Does everybody get the idea here? Right? I'm plugging in those fractions. Okay, so we're kind of messed up. So let's look. So out of that, I can only find 2. I need how many at most? 4. And we can literally see that there's 1, 2, 3, 4 on our calculator, correct? And we found 2 of them. So now it's going to go right back to what Haley said. Well, what's another option I can do? What's another option I can do? I know one of the factors is going to be what? X. I know the other factor is going to be what? X minus 2. So can I do long division or synthetic division to break this down? Yes, I could do long division or synthetic division. So when I look at that, I can use this X, but I already GCF'd it. So let's ignore it. Let's just work off of this guy. And so X minus 2 is still going to be a factor. Do you agree? So let's do, what do you want to do? Do you want to do synthetic or do you want to do long division? Your decision. I'm going to try synthetic. Is that good for you? So let's do synthetic. And I'm going to do it with this polynomial. I'm going to do it with the 10x squared. So what did we say the 0 was? 2. I'm going to put it down here just because I have no room. And so what digits are we going to put along here? 10, -15, -16, and then what? 12. Anybody bothered by the fact that we're not using the x? Because we've already kind of divided that. And so this would be the remaining factor. If I took the x and I divided it, this is what you would get. So now what are you going to do? How do you do synthetic with this? You drop the 10. And then what is 2 times 10? 20. Add those together. You get what? 5. And then what do you want to do? 2 times 10, or 2 times 5, 10, -6. And then what are you going to get? -12. Did we do that? Did we know that was going to happen? Did we know we were going to get a remainder of 0?
Yes.
Yeah, because it was a factor. Like we already knew it. And so that's why we know. And so now what is this going to be? It's a depressed polynomial. So it started out as a what? X cubed. So now we know it's going to go down to what? So you're going to get 10x squared plus 5x minus 6. Now here's the catch. Is this going to factor? And I'm going to tell you. The answer is no. Why do I know the answer is no? Because we picked out all the ones that worked here. This is all the ones where you set it equal to 0 and you get a nice little fraction answer. Does that make sense? So I know it's not going to factor. So what do you want to do? Well, I need to find the rest of them. So let's go this route. And again, I'm putting it all together. Intervals of length 1 where 0 lies. Where A0 lies, I should say. So let's look at that. So what are the intervals of length 1 where a 0 lies? There's my graph. What's this one going to be? We said this was what number? We got 1, 2, 3, 4. Maybe I need to zoom in there. I don't think I want to do that. I have to wait till the graph's. Now I'm going to go zoom 6. Zoom 6, got to get back to normal. Where does it look like it's between? Between -2 and what? -1. What's this one look like it was between? Now I'm going to go back and what did I say that window was? -4 to 4. -2 to 4, I think is what it was. So between -1 and between -2 and -1 and between what? Was it at 1 or between 1? So between 0 and 1. Where's the other one between? That's it, right? Because we only have 2. So now what do you want to do? Approximate. So if it says to approximate, what do you want to do? 0 button on your calculator. So let's do it. Second calc, 0. Get to the left. Get to the right. What is it? -1.06. And then what's the other one going to be? Second calc, 0. Get to left and to the right. What's it going to be? Point what? 56, 0. Now, what could I have done? Just as a reminder, because I think it all goes together. All your math just all ties together. If I wanted to approximate it by hand or get an exact answer, what would you do? You could do 2 things from right here. That's all you got. You can quadratic formula, or you can do what? Complete the what?
Square.
You do either one. That's all your option because it's not going to factor. And if you did do the quadratic forming and you did complete the square, that would give you an exact 0. But it sure is not going to tell you where it is. You'd have to use the decimal form to get the approximation. Does that make sense? So it would be an approximation regardless. Do we need to do quadratic formula just as a recursor? Just to make sure we're fresh in our mind? Yeah, let's do it just because it's fun, right? So what's the opposite of B? -5. Plus or minus, what's B squared? 25 minus 4A, what? C, all over 2 times what? 2 times A. So now what are we going to get? -5 plus or minus, what's this all going to be? What's 40? 40 times 6 is what? 240, so it's positive 240. 25 plus 240, all over what? 10. Oh, then what? -5 plus or minus?
Would it be
20? Be 20 on the bottom when you multiply 2 times 10 on a good day. Yeah, you're right. And then But if you're sitting through a lecture for a long time, it kind of gets lost in it. And then 25 plus 240, what would that give me? That'd give me 245. Do you agree? On a better day, 265. I'm glad you guys are here, showed up today. So 265. Now what are you going to do? Can you that doesn't look very good. Let's square root of 265. Okay, can you rationalize that? Got any perfect squares in 265? What do you think? Any perfect squares in 265? You think? I think there could be. I think that'll reduce down. 265. Tell me the first one that finds the factor. 265. 265. What would be another one? 265. 9. I'm not seeing it. Are you seeing it? Nope. So that's good. Let's just type that sucker in the handy dandy calculator now. Let's type in -5 plus the square root of what? Of 265. Get your answer. And then divide that by what? 20. Oh, what should the answer be? Yay, look at us. 0.56, right? We found it by hand. And then let's do the other way. -5 minus the square root of what? 265. I bet you're just jumping out of your seats. Divide by 20. What's that going to be? Oh, looky there. Got -1.06. Is that not fun? So that was like all of your math just all come together in one great big problem. That's pretty exciting, right? That pretty fun? That's pretty exciting. So it all just came together. Yeah, so what's the moral of the story? Make sure you read the directions. Only do what the directions are asking. Good to go? Don't do any more work than you have to. Correct? Correct. Okay, there you go. So